question number 4. 4a, internal resistor for all battery enable and calculate the current I1, I2 and I3 when the switch is open. So when the switch is open, meaning no current flow, so meaning the I3 is equal to 0. So meaning you have a I2 and I1. So to calculate the I1 and so now the answer for the I3 is equal to 0. So what is the value of the I1 and I2? So to calculate the I1 and I2, you can use the Kirchhoff law. So the first Kirchhoff law is total I in is equal to total I out. So meaning this is if you consider the I1 and I2, meaning I1 is equal to I2, right? So this is the current flow in the circuit, right? So we have a junction here because I3 is equal to 0. So if you have the I2 is equal to plus I3, but the I3 is equal to 0, meaning I1 is equal to I2. So, and the second Kirchhoff law is a total EMF is equals total drop voltage, right? R. So meaning you can use the loop here. So I draw the loop. So start from here because the current flow here and here. In the center we don't have the current flow, meaning you just consider the blue color loop. So start, this is a 12 volt, so continue loop, and this is a 9 volt because this is positive, so this is negative, meaning opposite you must use a negative 9, and follow the loop. So we have the current flow here is I2, drop voltage, this is equal to drop voltage is a I2 times 8 ohm, and the next is I1, the one direction same to the loop, so this is I1 times I1 here 7, right? Okay, but the value of the I1 is equal to I2, meaning you can find the value of the I1 or I2 from the equation here, because I1 is equal to I2. So now the I1 is equal to 0.10.20 and also is equal to I2, right? The net is total EMF is equal to total drop voltage, right? So the first equation is come from the first Kirchhoff law. So this is first Kirchhoff law, and the second is the second equation is second Kirchhoff law. First is so I draw the loop here. This is the first loop, and this is the second loop, right? So the first loop and the second loop here. I have forgotten to square up the radius. So start with the first loop. You can have a 12 volt and follow the loop. So we have this is the direction of the loop and this is the direction of the I3. So meaning you have a negative I3 because direction I3 opposite direction to the loop, right? Time 4 ohm and continue the loop. So you have a I1 and direction I1 is same direction to the loop. So you have the plus, this is I1 times 7. So this is a second equation, right? And the third equation is come from the second loop. So start from the 9 volt is equal to, follow the loop. So direction of the loop, opposite direction to the current I3. So when you have the I3 times 4. Okay, and the same here is direction of the loop, opposite direction to the current flow I2. So you must use negative I2 times 8 ohm back to the battery. So now you have this is third equation. So now you can use simultaneous equations, or you can use equation number 1, equation 2, equation 3 to find the value of the I1, I2 and I3. So this is mathematical process that you can use, and just give you the final answer. I1 is equal to 0.93 ampere, and I2 is equal to this is negative, 0.44 ampere, and I3, so we have a negative 1.37 ampere. Okay, the next question number B, figure 4 show the two resistor 250 ohm and 500 ohms series in battery 6 volt. Calculate the potential difference across A and B. So what is the potential here, A and B? So this is a potential divider. So to calculate the potential difference AB, so you can use the equation. This is R1 over R1 plus R2 and time the value of the 6 volt battery, right? So now the R1 is equal to 250, and the R1 is 250, and the R2 is equal to 500. So the final answer, the VAB here is a 2 volt. Thank you.